Good day, this is Jim Pytel from Columbia Gorge Community College, Renewable Energy Technology Program. This is Digital 3, ET 123. Today we're going to have a very quick discussion about magnetic and optical data storage. Primarily, it's going to be so quick is because everybody's seen this stuff before and everybody uses it on a pretty much daily basis. So remember these guys right here? That's the only use for them nowadays. These are little 1.4 meg floppy diskettes. That's a picture. There's no use for these things besides coasters. So if you have these things laying around your home with Pac-Man or Tetris on it, throw them away, please. But we are actually going to deal with some of our magnetic hard disks. You know, we've been dealing with these RAM and ROM and flash, which are very compact memories. But a hard drive, and the other ones have no moving parts. This guy, a hard drive here, is basically really is a spinning disk of magnetic material, a bunch of different types of magnetic material, and it's located on this spindle in the center, and it just spins around. And what happens is you have this stationary arm, and that's called an actuator. And at the very tip, if you explode the view of this thing, boom, there's a read head and a write head. And it's floating over the surface of this magnetic material. And this guy's spinning at like 1,000 RPM or faster. And it's organized in two ways. First, there are sectors radiating outwards. And then there are tracks. And the easiest way to remember it, a track, like track in high school, you're running around in a circle. How fun is that? You know, that's a track. And then the sectors, they're radial, radiating outwards. So track A, sector A, track 1. Sector A, track 3. Sector B, track 1. Sector B, track 3. Okay, so that's how those things are addressed. And how these read and write heads work is, so magnetism, you know, there's a polarity to something. This is an individual section of the magnetic material here. And it can have a polarity north and south, or it could have a polarity south and north. So one way is a 0, one way is a 1. Let's just pretend that's a 0 and that's a 1. So you want to store a 1 at this spot. What that write head does, it's a little electromagnet. You apply voltage to it, and these little magnetic fields lines come out there, and sufficiently enough to zap that thing to the other way. Now you want to erase it. You provide different polarity, north to south, and you're back to 0. So now you want to read it. What happens is basically, yeah, that right guy turns off. The disk spins, which is an effect. The actuator head just moves over a little bit there. Now the read head is over it. And what's happening here, as that moves, you know, remember, like moving magnets will create an electrical field. Moving electrical field, we'll make a magnetic field. So vice versa, we've moved a magnetic field. We're going to create a little voltage pulse here if there's a 1 on it, and an absence of a voltage pulse if there's a 0 on it, or a different type or a different polarity, voltage pulse negative. So that's how a read and write head works. They're all in the same thing. So for obvious reasons, with these things spinning at 1,000 RPMs, you don't want to be taking a hard drive up on a roller coaster or anything like that, because that's basically this actuator head here. It's spinning at 1,000 RPMs, and the slightest wobble in this hard drive here, it's going to crash into it, and it's going to be moving like an ice cream scooper at 1,000 RPMs and just gouge the surface of this magnetic disk. And because it's spinning at 1,000 RPM, put like this long scratch, this long furrow there, and that's all your favorite data that's gone, and you've crashed that hard drive. It's the actuator head crashing into the magnetic material and destroy that drive. The other thing that destroys these things is particles of dust. Here's this giant particle of dust, this big rock that's on there, and again, spinning at 1,000 RPM. Snap, just snaps that actuator arm off, or the read and write head go flying. So for those reasons, you don't take these things on roller coasters when you're trying to access your important data, and it's sealed. Your hard drive is typically in a sealed, dust-proof box, and you're trying to do your best to make sure water and dust are not being blown into these things. Some of these wind turbines, you're located in some very dusty areas, so make sure your cabinet doors are closed and stuff like that, because eventually all that dust may seep in there and cause some problems for these things. Like I said, okay, we talked about tracks and sectors. One of the things that should be in the back of your mind is like, okay, yeah, I got this address and that data is stored in it. Like, how the heck does the computer know where I put anything? Well, this is not really a computer class, but the easiest way to describe this thing is it's organized in files. Everything on your hard drive is organized into a file, and that's how you do it. Your basic output system, your operating system, whether it's DOS or Unix or anything like that, that's what keeps track of it. And how it does it is these two things: is the file allocation table, often called the FAT. And then the other one is basically your root directory, which is your file names. And oftentimes is your file name, it's going to tell you where it starts, where this file starts, and where this file ends. And to go back to the FAT here, is basically, it's telling you also, it's also keeping track of, okay, I store data on this sectors and these tracks, these sectors and these tracks, but those ones are open. So it's the file allocation table is things that are open, like tracks and sectors that are open, ones that are used, and ones that are bad. Not necessarily bad as you've ice cream scooped the heck out of these things or dust particles on it. It just may have had some erroneous data on it or something like that, and it may require you to format, i.e. to blank out that section again, just to make sure you're starting there. So 3 things that the file allocation table takes care of is the open tracks and sectors, used tracks and sectors, and bad tracks and sectors. What else do we want to talk about? Magnetic, nothing. So let's move on to optical data storage. Optical data storage, you are typically, optical data storage nowadays is your CDs, which are like shiny little records. And how those are actually done is you look microscopically at them, there's little pits and lands. One's a 0, one's a 1. And a laser And this is coming out of the factory like this. This is just a plain old regular CD-ROM. Laser hits this guy, bounces off, and let's say that's a 1. Laser hits this guy, bounces off this pit here, but it's changed polarity. You know, like light can travel. How to describe this? How to in 3 dimensions? Here, let's see. Light travels like that, or light could travel like that. So one polarization is a 1, one polarization is a 0. So that's the basic for optical data storage. But there's kind of different subcategories for your CDs. First one, obviously, plain old CD that you get off the shelf. That is basically a worm. That's, I don't even know if anyone buys CDs nowadays, like at a record store. You know, I don't even know if record stores exist anymore. That's one time. Write once, read many. Of course, it's read many. You know, at some record store, they're writing MC Hammer's song on there, and you can read it as many times as you want to. You can't change it. In contrast to a CD-R, which is kind of the same thing, but you get to record onto it. And rather than these lands and pits, that actually uses a dye. Well, very similar. It changes the polarity of these waves. CD-RW, CD rewritable. You know, you can write it once, write it, erase it, write it again. And that's again using a laser. Last one is a DVD. And that's just like a CD, but that's double-sided. Whereas a CD, it's only got one side. A DVD has got data on both sides. And to make matters, to make more data a little bit more dense, what you can actually do is make multi-layer DVDs. So the red laser goes in so far, whereas, let's say a different color can penetrate a little bit further into that thing. So what you can actually do is have more data stored on there. You know, the red laser is reading something, blue laser is reading something else on top of it. So DVD, that was for a video application, but you know, now you're seeing a DVD as a data storage devices too. So that is a super quick discussion about magnetic and optical data storage. There's a synthesis of these things called magnetic optical data storage. MO, magnetic optical data storage. It's very similar to magnetic, but for those things to change polarity, like we were doing here, rather than just having a write head, just apply voltage, you got to heat the thing up first. You got to shine a laser at it. So you shine a laser at it, then you provide a magnetic pulse and it changes polarity. So they're a little bit more stable than a traditional magnetic device only. Magnetic optical, it requires both a voltage pulse and a little laser to heat it up. So that is it about magnetic and optical data storage.